Welcome, everyone. Today we are going to move on to chapter 10 in the textbook, which is inferences for two population means. All right, so again, I wanted to mention here that some of the examples that you're going to see are adapted from the notes by Rosman and Chance. It's called Workshop Statistics, and the examples are coming from topic 22. All right, so we're going to look at two examples. And the first one is we are looking at two commuting routes, right? One of them has a sample mean travel time of 32 minutes, and the other one has a sample mean commuting time of 28 minutes. And what we would like to do is we would like to know how can we assess whether the first route is really slower than the second, right? So that's the first example. And the second example is, well, do you think women tend to pay more for their haircuts than men do? All right, so again, in this class, we're trying to make inferences about the population. So the question I have for you all at this point is, how are these two examples different than what we have learned so far? All right, so again, we're trying to answer a question, and what we're going to do is we're going to collect sample data to make inferences about the population. All right. The difference here is we are going to compare two different population parameters. All right. So we are in the first one, we are comparing the travel time for route 1 versus route 2. And in the second example here, we are going to be comparing the amount of money women pay for haircuts as opposed to what men do. All right. So the difference here, in Chapter 8 and Chapter 9, we learned about confidence intervals and hypothesis test for one population mean. However, we are going to use in this chapter inferential statistics to compare means of two populations. All right, so hence the title, Inferences for Two Population Means. All right, so broadly speaking, in this chapter here, we are going to be examining inferential procedures for comparing population means of two populations, right? And the type of procedures we use is going to depend on the type of samples we pick, right? And we are going to really be working with two types of samples. The first one is what we're going to call independent samples, and the next one are what I call paired samples. All right, so here's the definition. We say two samples are independent if sample selected from one of the populations has no effect or bearing on the sample selected from the other population. Right, so this should sound somewhat familiar. It is independent. We've talked about the notion of independence. Next, we say two samples are paired or matched when, for each data value collected from one sample, there's a corresponding data value collected from the second sample. So in other words, we are going to be looking at two samples that are paired or matched with one another. Right, so maybe this sounds somewhat convoluted. Let's look at an example that will hopefully clarify these concepts here. Right, so example 1.1, so let's assume we give a group of students a COVID-19 awareness test. All right, so what we're going to do is we're going to measure their awareness of the dangers of social gathering to the spread of COVID-19. All right, so we give them a test, and then what we do is we show the students a film about how large social gathering helps spread the disease, and then we administer the test again. All right, so what we're doing in this case here is we're measuring the same student twice. Once before watching the film and again after watching the film. Are these samples independent or matched? So we have a test score from students before they watched it, and then we have a sample after they watched the video. So are these independent or matched? Well, they're matched or paired, right? Because remember, it's the same student score before and after they watch a video. So if we're data set in our first sample, there's going to be a corresponding data in the second sample. So this is a paired sample. or matched sample. And this is a classic example of a paired sample, which is like a before and after test. All right, so we looked at the student before, right, and then we looked at the students after they watched the video. All right, so example 1.2, now let's say we want to calculate the difference in mean systolic blood pressure between men and women. So we pick a random sample of 1,000 people and calculate the sample mean of blood pressures for men and women in the sample. So we just pick 1,000 random sample and we calculate the sample mean of blood pressures for men and women in the sample. Well, what do you think? Are these samples independent or matched? Is there any way that we can pair the data from the first sample to the second sample? The answer is no. The first sample has no bearing on the second one. So this is an example of an independent sample. And finally, let's look at example 1.3. Suppose that we're interested in estimating difference between the mean weights of all participants before and after a weight loss program. So to accomplish this, we take a sample of 40 participants and measure their weights before the program and after the completion of the weight loss program. So the questions are these samples independent or matched? And we know these are matched or paired because we are looking at the same person before and after the weight loss program, right? So for each value in the first sample, there's going to be a corresponding value in the second sample. It's similar. All right, so these are matched. So now that we have a notion of what independent and matched samples are, we are going to talk about inferential procedures for these two different types of sample, starting with independent samples.